Hello, you are welcome to my channel. The question I have here says a 0.1 meter thick window has an area of 0.5 meter square. The outside temperature is 18 degrees Celsius while the room temperature is 30 degrees Celsius. If the coefficient of thermal conductivity of the window is 0.25 watts per meter per Kelvin, how much heat flows through the window each second? So here we have to calculate the heat flow per second. Now let's start with what we are given from the question. So I'll write given. I want us to pick out what we are given by their letters or symbol. So the first thing we are given here, we are given the thickness. And that thickness is usually written as L is equal to 0.1 meter. Now the next thing we are given the area. That is letter A is equal to 0.5 meter square. And then what else are we given? We are given the lower temperature. We have the lower temperature here and the higher temperature. So the lower temperature is T1, that is 18 degrees Celsius, and the higher temperature is T2, and that is 30 degrees Celsius. Now we are given the coefficient of thermal conductivity, and that coefficient of thermal conductivity is represented by the letter K. So we are going to say K is equal to 0.25 watts per meter per Kelvin. So this is a constant value. And then we also find the heat flow through the window each second. So that will be Q all over T. That is the heat flow per second, which is in watts or in joule per second. And this is question mark. That is what we are looking for. So we are going to apply the formula now that connects all these parameters so that it will be easy for us to solve. Now the formula to calculate this heat flow per second is given by Q over T is equal to K, which is the coefficient of thermal conductivity, multiplied by the area, and then multiplied by the higher temperature, which is T2, minus the lower temperature, which is T1. This is the temperature difference or the temperature gradient. And then all divided by the thickness, L. So now that we have the formula, we can substitute right away and obtain the answer. So I have K, which is 0.25, multiplied by the area, which is 0.5, multiplied by the higher temperature T2, which is 30, minus the lower temperature T1, which is 18. And then all divided by the length, which is 0.1. 0.1. So this will simplify further to give us 0.25 multiplied by 0.5 and then multiply by 12. 30 minus 18 will give us 12. And then everything divided by 0.1. And then by the time we divide this, when we multiply this 3 times here and divide by 0.1, we are going to get the rate of flow of heat, that is the heat flow through the window per second, as 15 joules per second. And this is the final answer. I hope you enjoyed this video on thermal conductivity of substances. Thank you for watching, and I'll see you in my next video.